Welcome back, everyone. Today is our last day of special derivatives, okay? And we're going to be talking about the derivatives of the sine function and the cosine function and the tangent function. Well, I think that sine and cosine function are much more important so far. So we're going to do those today. So if y is equal to sine x, then y prime is equal to cosine of x. And if y is cosine of x, then y prime is equal to negative sine x. So it's actually a cycle. Let's say we start with y equals sine x. Well, the derivative is cosine x. What's the derivative of cosine x? Well, that's going to be negative sine x. What's the derivative of negative sine x? Well, we know the derivative of sine x is cos x, so therefore the derivative of negative sine x would just be negative cos x. And what's the derivative of negative cosine x? Well, regular cosine x would be negative sine x, so therefore negative cosine x would give us positive sine x. And we're back to the beginning, right? Because then what's the derivative of sine x? Cos x, then negative sine x, then negative cos x, then back to sine x again. So it's actually a cycle, and I wanted to show how it's actually a cycle. It keeps going and going, where we start with one of them and then we just rotate, basically. So every fourth derivative here in this case is just going to be sine x again. Every derivative that's 1, 5, and so on is going to be cosine x, and so on and so forth. Now the chain rule still applies here as well, where if we have a sine of a function, we also must remember to take the derivative of what's inside the brackets. And this is the mistake I see lots of people making. They think, they remember to switch from sine to cosine or from cosine to sine. They remember the negative sign for the most part. But what sometimes people forget is that you also must take that derivative. So that's very important. Awesome. Okay, so let's start with some examples, just some nice simple examples here. Number 1 says differentiate these 5 things. So the first one is cosine of 4x. So to differentiate that, I'm going to say that is the same as negative sine for x, right? Because cosine goes to negative sine when we take the derivative. And then also we must use the chain rule and multiply it by the derivative of what's inside our brackets. And what's inside our brackets is 4x. So the derivative of that is 4. So that's equal to negative 4 sine 4x. Very good. Let's try this next one. Excuse me. Okay, so let's try this next one. This is going to be cosine x squared. So therefore, we're going to have negative sine x squared times what's the derivative of what's in the brackets, which is 2x. So that's going to be negative 2x sine x squared. There we go. We did it. All right, and what about this next one here? Here we have to apply the the power rule as well, but I meant to say the product rule. So derivative of the first, which is 2x, times the second, which is sine x, plus the first one, which is x squared, times the derivative of the second one, which is cosine x. And there we have it. Okay, and then here we have sine squared of 3x. So to do that, what I'm going to do is I'm going to say, well, we must apply our power rule and chain rule here and say y must be 2 sine 3x times the derivative of what's inside our brackets, which is cosine of 3x, to chain once, and then we chain again. What's the derivative of what's inside the 3x brackets? Well, that's going to be 3. So our answer in total, I should have put y prime, that's not y, is 6 sine 3x cosine 3x as well. So that example was interesting because we had to chain twice, which was pretty interesting. Okay? All right, and our last one here, let's figure it out. It's going to be y prime is equal to e sine x cos x, times the derivative of what's on the top. So the derivative of sine x is cos x, and the derivative of cos x is negative sine x. So that's what we would multiply it by there. Very good. All right. All right, example 2 says determine the equation of the tangent line to the curve f of x equals x times cos 2x at x equals 2 pi over 2. Okay, so first of all, determine the equation of the tangent line. So to find the equation of the tangent line, first we must find the slope of the tangent line. So let's do that. The slope of the tangent line is the derivative, which for this example, we must use the that too, but we must use the product rule to solve it. So derivative of the first one, which is x, right? So derivative of x is just 1 times our second one, cosine 2x, plus the first one, which is x, times derivative of the second one, which is negative sine 2x times 2. So that's equal to cos 2x plus 2x, or sorry, negative 2x sine 2x, like that, just like that. All right, and now I'm going to plug in my pi over 2 value. So this is going to be cos pi minus 2 pi sine pi. So let's think, well, what's cosine of pi? If we think about just our parent function trigonometric graph, we'll recall that cos of pi, right, pi is right in the middle here, is negative 1. So that's negative 1. And what about sine of pi? Well, it goes like this, so it's 0. So it's negative 1 minus 0, which is just negative 1. So there we go, right? Because I'm going off of 0 times the 2 pi, right? 0 times anything is equal to 0. So whenever we have things like pi over 2, pi, 3 pi over 2, 2 pi, don't forget that, I mean, you can use your calculator if you'd like to. That works as well if you're allowed a calculator for the test. But you can also just know based on our parent functions of the exponentials. All right. So now we know that y is equal to mx plus b, and x is negative 1, or sorry, m is negative 1, so negative x plus b. Now we need to find one point on the graph, and we already know that a point on the graph is going to be pi over 2 comma negative pi over 2, right? If I was to plug pi over 2 into the original equation, I would get negative pi over 2. Okay, so that's going to be my x and y values. So therefore, negative pi over 2 is equal to negative, right, the negative from here, pi over 2 plus b. So therefore, b is equal to 0. So therefore, our equation is y is equal to negative x. And there we have it. There it is. Now, it is important, I should make a note here, it is important to find b. In this specific example, that it is true actually that if you forgot, you would still end up with the right answer because b is just 0, but that doesn't mean b will always be 0 in every question like this, so it's important to check and make sure for sure that b is 0 before just assuming it, because it will not always be 0. All right, time to move on to a couple more examples here. All right. So this one says determine the maximum and minimum values of g of x is equal to cosine squared x on 0 comma 2 pi. So on that first full cycle. So let's do it. Let's do it. So we know that in order to figure that out, we need to first find the derivative, right? Because the derivative, as we know from the previous unit, it gets us those critical points. It gets us what's the minimum and what's the maximum, okay? So let's do that. The derivative is equal to 2 cosine x minus sine x, or times negative sine x, I should say, which is equal to negative 2 cos x sine x. Now, if we set that to 0, we have 0 equals that stuff, which means what? Well, if cosine x is 0, then this whole thing is 0, right? Going back to quadratics, going back to the zero product property. And same with if sine x is 0. So basically, if either cos x must be 0, we'll make the whole thing 0, or sine x would be 0. Now, when is sine x 0? If we recall from our graph, right, I'm just going to do a rough sketch here, at 0, pi, and 2 pi, right? Oh, sorry, that's sine. My apologies. I wrote that for cos. It should be for sine, okay? And then what about for cosine? For cosine, if we recall, there's only 2 zeros instead of 3, and it's going to be pi over 2 and 3 pi. Oh, oops. Not a very good drawing, but 3 pi over 2. Yeah, that's not a great drawing. Don't look at the drawing. But yeah, recall that those would be the 2 points. It would be x is pi over 2 and 3 pi over 2, like that. So now let's figure out what's maximum and what's a minimum, okay? So we have g of 0, where we're going to get 1. We have g of pi over 2, where we'll get, let's see, if we put cosine squared pi over 2, we get 0. Then we get g of pi, where we get 1 again. Then we have g of 3 pi over 2, where we get 0 again. And then we have g of 2 pi, which is 1. So therefore, we know that the maximums must be the 1s, right? And the minimums must be the 0s, right? Because 1 is a larger number than 0, and we know these are where the critical points are in these places. Of course, there's infinitely many, but in this case, they only asked for this interval, so therefore I only did this interval, but we could generalize this to more values if we used, k as, in order to scale these, but these are the only values asked for. They didn't ask us to do that, so I won't be doing that here specifically, but it is good to know that we could do that if that was something that was asked of us, or if that's something we wanted to do and try. All right, the next question says, find the derivative of y equals tan x. So you might be saying, well, how do we find it? We need to be told what it is. And that's true. We could be told what it is, or we could find it. Recall that tan x is equal to sine x over cosine x. And also recall the quotient rule, right? If we know the quotient rule and we remember that tan x equals sine x over cosine x, we can actually discover the derivative for ourselves instead of just knowing it. Now, or you could just look it up online and it will pop right up. That works too. Or you could find it and then see if you're right. So let's go for it. So if y is equal to sine x over cosine x, that means that y prime would be the derivative, right? The derivative using the quotient rule. So derivative of the top, which is sine x, would give us cos x times cos x minus sine x, right, times the top one, multiplied by negative sine x, so derivative of the bottom there, over cosine squared x, right, the bottom squared. So that's equal to cosine squared x plus sine squared x over cosine squared x. And recall also that cosine squared x plus sine squared x is equal to 1. That's probably one of the first identities you guys learned. What's going to be 1 over cosine squared x? And that means that y prime is equal to secant squared x. So therefore, the derivative of tan is secant squared x. Okay, so now we're going to apply that. Now we're going to apply this. So let's differentiate these three things by applying this rule that I was going to say that we just made up. No, this rule that we just learned from doing some good deducing. Okay, so for this first one, we're first going to change the tangent to a secant squared and just keep the middle the same, keep what's inside that function the same, and then we're going to multiply by what? We're going to multiply by the derivative of what's inside the function because that's a chain rule. So here we'd get 2 plus 3x squared using the power rule twice, and the chain rule as well. What about for b? Well, in this case, we're going to use the chain rule to say that it's going to be 3 sine x plus tan x squared, right? So first part of the chain rule times the derivative of what's in the bracket. So derivative of what's in the brackets, let's see, well, derivative of sine x is cos x plus derivative of tan x is secant squared x. Like that. Awesome. Okay. What about c? C. So for this one, we're going to have to use actually the chain rule and the product rule to solve it. So in this case, y prime would be derivative of the first one, which is just 1, times the second one, which is tan 3x minus 1, plus the first one, which is x, times the derivative of tan 3x minus 1. So what's that? That's going to be secant squared 3x minus 1 times the derivative of what's in our brackets, which is 3. So if I just make that a little bit neater, it's going to just be tan 3x minus 1 plus 3x secant squared 3x minus 1. I just wanted to kind of neaten up our coefficients a little bit, make them look a little bit better. But there we go. There we have it. All right, well, that is it for today, and actually that is it for this unit and the calculus section of calculus and vectors. The next lesson will be an introduction to vectors. So that'll be very good. We will do that in the next day. Good work today, everyone, and we'll see you for the next day. Goodbye.